about a whale is that if its origins were land-based originally, then we have some crude way of assessing quantitatively, not qualitatively, but quantitatively, the scope of the project of transformation. The project is very simple. Let's put it in vividly accessible terms. You've got a cow. You want to teach it how to live all of its life in the open ocean, still retaining its air-breathing characteristics. What do you have to do from an engineering point of view to change the cow into a whale? This is crude, but it gives you the essential idea. Now, if the same question were raised with respect to a car, and you ask what would it take to change a car into a submarine, we would understand immediately it would take a great many changes. The project is a massive engineering project of redesign and adaptation. Well, the same question occurs with respect to that proverbial cow. Virtually every feature of the cow has to be changed. It has to be adapted. But since we know that life on Earth and life in the water are fundamentally different enterprises, we have some sense of the number of changes. Anytime a science avoids coming to grips with numbers, it's somehow immersing itself in perhaps an unavoidable, but certainly an unattractive miasma. Here's a chance actually to put some numbers on calculations. We're not talking about genetics. We're talking about simple numbers. The skin has to change completely. It has to become impermeable to water. That's one change. Breathing apparatus has to change. A diving apparatus has to be put in place. Lactation systems have to be designed. The eyes have to be protected. The hearing has to be altered. Salivary organs have to be changed. Feeding mechanisms have to be changed. After all, a cow eats grass, a whale doesn't. As I say, I've tried to do some of these calculations. The calculations are certainly not hard. But they're interesting because I stopped at 50,000. That is morphological changes. And don't forget, these changes are not independent. They're all linked. If you change an organism's visual system, you have to change a great many parts of its cerebellum, its cerebrum, its nervous system. All of these changes are coordinated. So when we're talking about an evolutionary sequence such as this, what's interesting about the cow to whale transition, and I'm just using this as a easily accessible idea. What's interesting about the cow to whale transition is that we can see a different environment is going to impose severe design constraints on a possible evolutionary sequence. How are these constraints met if they're roughly 50,000? If they're 2 million constraints, how are those met? And what does this suggest about what we should see in the fossil record? To my way of thinking, if Darwinian hypotheses are correct, it should suggest an enormous plethora of animals, intermediary between, say, Ambulocetus and the next step. That won't solve all problems. One wants to know what's directing this change, if anything. But at least it will put it in the ballpark of a quantitative estimate, which is hardly ever done.